Okay, in this video I'm going to be going over what is logical volume management. In computer storage, logical volume management, or LVM, provides a method of allocating space on mass storage devices that is more flexible than conventional partitioning schemes to store volumes. In particular, a volume manager can concatenate, stripe together, or otherwise combine partitions or block devices in general into larger virtual partitions that administrators can resize or move potentially without interrupting system use. What really is logical volume management? Logical volume management is a form of storage virtualization. How many different types of storage virtualization exist? There are two other types of storage virtualization that I know of besides LVM, and that is SAN and RAID. What are the pros of logical volume management? It's easy to add more storage with LVM. If a drive fills up, you can just add another to the pool, replacing hard drives with no downtime. If a drive starts making the ominous clicking noises, you can take it out of service without any server downtime. LVM allows for volume snapshots. Flexibility, you can create logical volumes of any size and shape and adjust them as your needs change. Efficiency, you can use all the available space on your physical disk without wasting any unused partitions. Striping, which distributes data across multiple disks for faster access. Mirroring, which creates a copy of a logical volume on another disk for redundancy and fault tolerance. What are the cons of logical volume management? Complexity. LVM is more complex setup than traditional data storage. LVM adds an extra layer of management and configuration to your storage system, which can make it more difficult to understand and troubleshoot. More resources, more kernel support is needed to repair images that might not work. History and risk of data corruption. Early versions of LVM had corruption problems, but it's been stable for a while. Learning curve. You need to be familiar with LVM commands and concepts and keep track of the relationship between the physical disks and volume groups and the logical volumes. Additional complexity. You need to be careful when making changes to your logical volumes, as operations may require unmounting or remounting of file systems, or may affect the boot process or the system stability. Single point of failure. Another drawback of LVM is risk. LVM introduces a single point of failure for your storage system. Any damage or corruption to the LVM metadata can render your logical volumes inaccessible or unusable. Storing and backing up metadata. You need to back up your LVM metadata regularly and store it in a safe location and be prepared to restore it in case of a disaster. Data loss and inconsistency. You also need to be aware of potential data loss or inconsistency that may result from using LVM features such as snapshots, which capture a point-in-time image of a logical volume but may not reflect the changes made to the underlying file system. And that is what logical volume management is.